let's copy UDP client to convert2.c. okay, we're just making a copy of that UDP client that we did earlier. Now in this convert2.c, we delete everything because we are not really interested in all these guys. Let's delete all of these guys. Okay, all this, even this guy, I think even H2NS, just delete this guy, delete. Okay, just to make this simple, probably we'll use this guy, inet address. Okay, and others just delete everything. Okay, we want to show, we want to identify what this particular function inet address does. Okay, so in order to understand this, let's do man inet address. Okay, the moment you do an inet address, what is the function you see here? Inet address takes a character pointer. Inet address takes a character pointer. And what is this character pointer? What is this? This is a string of the server name. And remember, in our case, the server is 127.0.0.1. So if I just put 127.0.0.1, this inet address will take it and convert it into Big-Endian format. See, this is what it does. Okay, just copy this guy. Okay, so from the man page, what did we get? Converts from IP version 4 address to network byte order, and we already know what network byte order is. Network byte order is NDN. Okay, this is what it does. Okay, so let's take the server name. Let's say const char server name equal to 127.0.0.1, and let's put the server name here, and it will return us an address. So let's call this int address equal to, it will return an integer type, and this is the server name. Okay, the input to this inet address is a string, and what is the output? Output is an integer. And what does this integer contain? This integer contains the actual network address in the Big-Endian format. Let's write this server address in IPv4 notation. Okay, let's print this guy. Okay, that's the server name or server address. And after this function is over, we can just print. Okay, we can just take from convert.c. Okay, rather than writing it, I'm just going to copy paste from this guy. Okay, print byte is the function that we wrote earlier in the previous class. We're just going to copy paste it. Okay, we can just print it. You can, rather than saying this, we can just say print byte. This function, we are using this function, print byte. And what's the first argument? The argument is the address. And what is the size? Size is 4 bytes. Okay, so first let's compile this, and then we can explain what's happening. So let's first cc convert2.c. This is what we have written today, and when we run it, then we can see that the server address in IP version 4 notation is 127.0.0.1, and after conversion, this is what we are getting, 7F001. Okay, so now what was the input? The input was this string 127.0.0.1, and what is the corresponding Big-Endian format? This is the Big-Endian format. This is the conversion that it does. Okay, so first let's take the output. What is it? 127.0.0.1. This is the one, and remember, this is a 32-bit number. 127.0.0.1 is a 32-bit number. So 127.0.0.1. Okay, this is our IP address. This is our IP address. This is the server IP address. Okay, and this 127.0.0.1, there is a dot here, no? So it's called dotted decimal notation. This representation of an IP address is called a dotted decimal notation. Dotted because there is a dot here, no? See, there is a dot here, there is a dot here, there is a dot here. Therefore, they are called dotted. So the first line is clear, I think. Dotted means there are 3 dots here, no? 127.0.0.1. 0.1. No wonder this is called a dotted decimal notation. And why is it called decimal? Because this is represented in decimal. Decimal means base 10. Okay, this is a decimal. Okay, this field also will decimal. This field 0 is also decimal. This guy is also decimal. All of them are in decimal form. Okay, so no wonder this is called a dotted decimal notation. So there actually, how are these numbers represented inside the computer? Is anything other than binary? Everything is binary, is it not? So if you write the binary for 127, what is the binary for 127? Remember this 0. This 0 will be represented by how many bits? 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. What about this other 0? It will be 0, 0, 0, 0, 0, 0, 0, 0. Another 8. Okay. What about this guy? 1. 1 is 1, no. So all others will be 0, 0, 0, 0, 0, 4, 5, 6, 7, and then there is a 1. This okay, no? What is the binary for 127? By the way, there is this famous BC calculator. You can put whatever and it will give you the value. Okay. So if you put this 127, what is the corresponding binary? 1, 2, 3, 4, 5, 6, 7. How many ones will be there? There will be 7 ones. Okay, I am just copy pasting.
7.
There will be seven of them, no? Okay, so let's put this here. There will be 7 ones. Of course, because 8 bits, so you have to have a 0. 0 is just 0. This 0, remember, is decimal. No, it requires 8 bits or 1 byte. This 0 is this represented by 8 bits. This 1 will be represented by all zeros except the last one. That's what is 1. 127 is slightly tricky. So what I'm using this calculator in Linux so that I can easily convert from any base to any base. So you just use this BC command and you can convert from any base to any base. So I'm just done it. So 127, its decimal, its binary is represented this way. Okay, you can clearly see that this guy here, this is also server IP. This is also server IP, but this time it is in binary. So hexadecimal mein how many bits are there in a hexadecimal number? 4 bits, no? Okay, and here also. What we are trying to do is this. We are saying we want to find the server IP, but this time not in binary but hexadecimal. If I put 0001, okay, if I put 0001 in binary, then what is the output in hexadecimal? 1, but this guy has a hexadecimal value of 1 and 00 is of course 0, so there is nothing to think about, it's just 0. What about this guy? This is 0000, hexadecimal will just be 0, no? This guy also, all zeros, it will be 0. This guy also 0. This 4 all of them are 0, so this will also be 0. All of them are zeros. If there are 4 ones, then hexadecimal, how do you represent it? You can just use the calculator. No, you put 1, 1, 1, 1. If you put 4 ones, then what is the value? The value is, hexadecimal value is F. Okay, I am cheating. This is F. And if there are 3 ones, 0, 1, 1, 1. So you can just type it 0, 1, 1, 1. Then what is the value? The value is, okay, the value is 7. Okay. Now we can see what is happening. When the server IP was 127.0.0.1, actually this is this long 32-bit binary. All you have to do is convert that binary into hexadecimal and you get the actual address. This is the actual data that is passing through the network. But 127.0.0.1 is for humans, for army ke liye, not for machine. How does the machine remember? Machine takes this IP address and just like we did manually, this particular IP address is remembered inside the machine, inside the computer as 7F000001. Right now, remember we compile this cc convert2.c. Okay. What was convert2.c? Convert2.c had what IP address? You look. What is the IP address? 127.0.1. 0.1. That was the IP address, is it not? And what is this IP address? This IP address, as we know, is the server IP, is in the dotted decimal notation. And after that, it converts it using this INET address, it converts it, and we print it, okay? And when we print it, what do we get? We get the hexadecimal notation. Now let's compile this, convert 2.c, okay, and run it, okay? And if you look at the output, what is the corresponding decimal representation? 7f, you look at this guy, 7f 000001. The output of the program is. And now you look at the figure, 7f 000001. Okay? We have just seen that 127.0.0.1 actually is converted into this format. So remember, what is the value? It's 7f 000001. But whenever we are reading from left and whenever reading to right, then we can write it as 7f 000001. That's what it is. When we read from right to left, that's also possible, na? Then what will we read? What is the first one in the right? 01. Then next one 00. Then again, see this third byte 00. And finally, what will be the value? 7f. Remember, when you read from left to right, what is it called? Little Endian or Big-Endian? First, to this number, what is the least significant byte? Okay, what is the least significant byte? 01. This guy is the least significant byte. This guy. This is the LSB. This is the MSB. Is it not? Most significant byte. So what did we say? In Little Endian, what will you do? In Little Endian, what do? We take the LSB. Okay. And what is the value of LSB? 01. We put it in the memory first. This guy, we put it in the memory first. Okay. And what is the next guy? This is the next one. You put it 00. And then you take this next one. Okay. Put it here 00. And finally, what do you write? The last one, the MSB, here 7f. Okay. There should not be any confusion. Whenever you say LSB, least significant byte, this is what is called the little end. Therefore, this representation, of course, is Little Endian. This on the right, on the red, it's Little Endian. Let's take another color for Big-Endian. So green. Okay. So remember, in Big-Endian, what do? You take the big end, and this guy MSB, most significant byte, is the big end. This is the big end. Okay. And you take this big end and put here first in the memory. Okay. That's how Big-Endian works, no? And what is the value? 7f. Then the next value is what? 00. And what is the next value here? 00. And then finally this 01, the MSB will come, the LSB will come here, and this will become 01. Okay. So now you read from this top to bottom, you read it like this. What do you see? 01, 01, 00, 00, 00, 00, 7f, 7f. Is it not? And here you start from reading from the top of the memory. 7f, 7f, followed by 00, 00, 00, 00, again 00, finally 01, this guy. So what do we see? The output that we got, 7f 000001, actually is in the Big-Endian format. Okay. So we have clearly seen that this 7f 000001 is in the Big-Endian format. Remember what we said. If you look at this code, okay, if you look at this code, remember that now we have to say that this guy, what does it print? This prints hexadecimal. What does it print? It prints 7f 000001. And remember, what is this? This is not only hexadecimal, it's hexadecimal and Big-Endian. Is it not? See, 7f 000001. And who is doing this? inet address is doing this. inet address is the function that takes a dotted decimal notation and converts into hexadecimal big endian.